Hello again. It's nice to see my face. We are kind of winding down here. There's only 3 more lessons I've got for you, including this one. So I know it's been a long spring, but things are just about to come to an end. So hang in there. We're going to get through this. We got a few more things to cover. Then we'll wrap it up and we'll call it a year and we'll try this again next fall. I'm going to switch over to the whiteboard and we'll get to work. So our topic for today is called the arithmetic of functions. And I just want to make sure you're really clear on what that means. Arithmetic is what you learned how to do when you were just very young, and that was to add, subtract, multiply, and divide numbers. So that's a term that should be reasonably familiar with you or for you. Now, this idea of adding functions to the mix simply means that, in fact, we can add functions together, and we can subtract functions, and we can multiply them, we can divide them. So I'm going to take you through 3 of those. We're not going to get through division today because it's a little bit trickier, but I'm going to show you what the process looks like for adding, subtracting, multiplying functions, and a couple of interesting results that come from these procedures. And then there is actually one other thing we can do with functions that you haven't really done before with numbers and arithmetic, but that'll wait for next week. All right, so let's start with a couple of functions here. I'm going to write f of x equals 3x minus 1, and g of x. And notice that I'll use f and g separately because they represent different functions. This can be a little bit more complicated. Plus 5x plus 13. Okay, so I have these 2 functions, and I want to add them up. So on one hand, you can write this as f of x plus g of x. And we'll do that in just a second, so this is the way your book writes it. But the really cool kids, they write this, f plus g of x. So you're allowed to use either one you want, the safe one up on top or the really cool one down the bottom. I'm okay with either one. So what does it look like to add these 2 functions together? Well, I'm going to take, let me do it this way. I'm going to take f of x, which is 3x minus 1, and I'm going to add that to g of x, which is x squared plus 5x plus 13. And at this point, this should look fairly familiar to you, because earlier in the year, we did add polynomials together. Remember that process? We would go through and say, okay, how many x squareds are there? Well, I just see the 1, so I'm just going to write that as x squared. Now, when it comes to x's, there's 2 x terms, but how many x's are there? I start with 3 over here, I add 5 more, and I get 8x. And then what about the numbers? I have plus 12. So I can write f plus g of x, or f of x plus g of x equals x squared plus 8x plus 12. Now, I want to just mention one thing real quickly, and that is, what do you suppose we might get if instead of f plus g of x, we did g plus f of x, which is another way of saying g of x plus f of x. What would that look like? Well, I would take g now, which is x squared plus 5x plus 13, and I would add that to f of x there, 3x minus 1. So let's see what that leaves us with. We have just the 1x squared, but then we have, again, these 2 x terms, 5x's and 3x's. Add those up, we get 8x's. And you know what? This is starting to look familiar to me. 8x plus 12. So we can see here that f plus g of x and g plus f of x are the same thing. So I can say, watch this, f plus g of x equals g plus f. And this is called the commutative property. So here we are in the last few weeks of the year, and we're going back and revisiting one of the properties we learned in the first few weeks of the year. And it turns out that addition of functions we say is closed, which means it works under the commutative property. Cool. Okay. Let's look at subtraction. Subtraction is a little bit different always. So again, I can write it f of x minus g of x, or I can write it f minus g of x. So f of x again is 3x minus 1. But now you got to watch really carefully, because this time I'm subtracting a whole other function. And I put the hard brackets in there just because I felt like it. There's nothing fancy about it. I could use parentheses. I just picked brackets there. And so now it's going to be x squared plus 5x plus 13. So now I hope you remember this, that there is, we have to distribute. And this is like there's a minus 1 out front. This is really 3x minus 1, watch this carefully, minus x squared minus 5x minus 13, which now comes out to minus x squared. 3x minus 5x is minus 2x, and then minus 1 and minus 13 more is minus 14. So f minus g of x is x squared minus 2x minus 14. Okay, great. Now, continuing on this process, let's look at g of x minus f of x. And again, we can write that as g minus f of x. Let's see if, like before, it comes out to be the same answer. And you might actually do some thinking about this from your work with numbers. Just think about what we're likely to get when we reverse the direction. So let's go back to, we'll go g of x now, so that's x squared plus 5x plus 13 minus, now this whole thing, 3x minus 1. See what I did there? I used parentheses and not brackets. Great. Yay for me. All right, let's go ahead and do this distributive problem again. So again, we have x squared plus 5x plus 13, and I have minus 3x, but that minus 1 and minus 1 makes plus 1. So altogether now I have x squared, 5 minus 3 makes 2x, and 13 plus 1 makes 14. So I'd like you to look real quickly at what this looks like and what this looks like, and see if you can recognize anything. Did you see that all the numbers at least are the same, but the signs are flipped between them? For example, we have this minus x squared, and this becomes plus x squared. We have minus 2x, it becomes plus 2x. We have minus 14, it becomes plus 14. So these are not, subtraction doesn't work under the commutative property. And that should be familiar from before. I don't know if you remember this. Remember, like 7 minus 3 was 4, but 3 minus 7 was negative 4. And so we have this, this negative positive relationship there. And we have the same thing down here. The same thing. Okay? So we're just really subtracting polynomial expressions. They could be more complicated expressions. I guess you could technically have square roots or cube roots or other things, but for the most part, we're sticking with just polynomials. All right, the last one is a little bit tricky, and that is multiplication. And I say it's tricky only because the process of multiplying polynomials can be a little bit messy. Remember when we would do like distributive property over and over and over again, or we would stack the answers and we have to find the like terms and add them together? It just takes a little bit more time, but here we go. So I can write f of x times g of x, or it's actually, I kind of like this, it's just written as f times g of x. You don't even really have to have any symbols in there, f times g of x. Okay. F is 3x plus 1. No, 3x minus 1. Excuse me. X minus 1. And g is x squared plus 5x. Okay. So what's this going to look like? Well, we got to go through the process. We're going to go distributive, distributive, distributive. Just follow along with me. First one is 3x cubed. The second one is plus 15x squared. And the last one is plus 39. Again, 3x times x squared, 3x times 5x, 3x times 13. Then what I'll do is I'll do these three distributive steps, which will be, the first one is minus x squared. I'm going to put it here just so I can be consistent by line up my like terms. Minus 1 times 5x is minus 5x minus 13. So I end up with 3x cubed plus 14x squared plus 34x minus 13. Okay, so that's what f times g looks like. Now, obviously, they're not all going to be that complicated. It would be a lot easier if it was just like x's and x's or even numbers. But what about this? What about 3 times 6? That equals 18. What does 6 times 3 equal? It equals 18, right? So we know that multiplication works or is closed under the commutative property. The question I have then is that going to work here? What is g of x times f of x? I will use the notation here. So let me just, we'll go through this. This is going to be x squared plus 5x plus 13 times 3x minus 1. And again, we're going to use the distributive property. So I'm going to go x squared times 3x, x squared times minus 1. So it's going to be 3x cubed. And you should be checking up here to see if things look familiar to you. So 3x squared, 3x cubed minus x squared. Okay, the next thing I'll do is I'll use the distributive property on this middle term and go 5x times 3x, that's 15x squared, and then minus 5x over here. And I'm running out of room, but I'll make it work. The last one will be 13 times 3x, which is plus 39x, and then 13 times minus 1 is minus 13. So all together, what do I have? I have 3x cubed. There was no others of those. The x squared terms were plus 14x squared. That's a good sign. Look right here. The x terms is plus 34x. Again, good sign. And finally, minus 13. So in fact, it does work. Multiplication, you can go back and forth in either direction. But subtraction, you can't. So the last thing I want to show you is a quick example of how we might do this with actual numbers. Let's just try this. We're going to try f of, how do I want to do this? How about this? F times g of 1. What if you actually plugged a number in to this problem? Maybe we'll do f plus g of 32 just for fun. We'll do these two examples. Okay, f times g of 1. Well, one option is you could go back and calculate this entire function here. You could calculate this whole function and then just plug 1 into it. But it's kind of cool to do something a little bit different. So watch this. What I can do instead is I can calculate f of 1. By the way, f of x is 3x minus 1, right? So f of 1 is 3 times 3 minus 1, which is 2, times g of 1. Oh boy, g was x squared plus 5x plus 13. But 1 squared is 1. 5 times 1 is 5. So 1 plus 5 makes 6. 6 plus 13 makes 19. And the answer is 38. 38. And what you can do, let me make this a little bit cleaner. Do right by you. 38. What you could do if you want is you could go back and you could plug in x equals 1 here and here and here and see if you get 38. I have a hunch you will. All right, let's try this last one, f plus g of 3. So I can, again, do this two ways. I'm going to do this f of 3 plus g of 3. But keep in mind, we could just go back and take this, this final function right here and just plug it through. Like, for example, 3 squared is 9. 8 times 3 is 24. So 9 plus 24 is 33. And 33 plus 12 makes 45. So let's just go over here and write down on the side here 45 as our guess. So f plus 3, sorry, f of 3, going back over here now, 3 times 3 is 9, 9 minus 1 is 8. Okay, g of 3, I'm now over here. 3 squared is 9. 5 times 3 is 15, so 9 plus 15 makes 24, and 24 plus 13 makes 37. So what is 8 plus 37? 45. So the bottom line is it's kind of cool to make the functions on one hand, but you can also do these arithmetic tasks on specific numbers. So, all right, that's going to be it for today. Here's your assignment. Remember, there's option 1. Will be, let me get it out here. From your book, page 448. And I want to make sure that you always have an option in your book, because you have your books. You know, some of you are not as able to download the worksheets off the website, and that's fine. But there are 2 other options here. Oh dear. I've lost my pen. Just one sec. Okay, I got it working. Option 2 is going to be a CUDA worksheet. You know and love those, right? 9 through 14 and 20. So just pick those special problems. And then option 3 it's another worksheet. It's labeled 10.2. If that isn't meaning to you. And that'll be questions 16 through 24. So if you want to play around, you can figure out which one has the fewest number of problems. I can't guarantee it'll be the easiest, but those are your 3 assignments. Those I'd like you to finish by the 22nd. Then I'll be back with you on Tuesday the 26th, with your next lesson. You get Monday off because it's Memorial Day. So I'll be back on Tuesday with your next lesson, another lesson the following week, and then we'll wrap it up with our test. Stay healthy, be well, see you next time.